Alright, this is the linear regression on the TI-84. So first thing you're going to do on your TI-84, which I have right here, is clear the memory. And I would like you to copy this note sheet by pausing the video. I'll zoom out so that you can get everything. And then pause the video so you can get the steps copied down. But clearing the memory is easy. You just turn the calculator on so that it's blinking. And then we're going to hit the blue button. This one here. Second. So you're going to hit the second, the addition sign, plus. And then you're going to choose number 7, which is reset right here on the calculator. 7. You can choose number 1, all RAM. And number 2 to reset. So what that does is it clears everything out. Anything you had in the y equals editor all goes away. Just clearing the RAM. To get out of this window, you can just hit second. Mode, right above mode says quit. Second, quit. It takes you back to the home screen. Alright, so each time you're using the TI-84 linear regression, you have to clear the memory. Alright, so let me zoom out a little bit. And we'll at least take it to this point here. And then I'll move this up a smidgen more so you can see what's on the bottom. But first, and hopefully you printed out this note sheet, it just makes it a little neater. You're going to clear the memory, second plus, 712. And then there's steps here on how to input the data, how to turn on your stat plot or your scatter plot, how to have the calculator calculate the regression slope and the y-intercept of that line of best fit, how to transfer your slope-intercept equation into the y equals editor, because you're going to find that the slope and sometimes the y-intercept have a lot of decimal places. And so, again, just pause the video and get these steps copied. Alright, hopefully you paused the video and got these steps copied. There's a couple more things on the bottom here, but I'll move the paper up. You'll have time to copy that. So we clear the memory, and I've already showed you how to do that. Now we're going to go to input data. Now, if you notice, you know, on the last note sheet that we did, we had this problem, and this is the problem that's on the bottom of this note paper. This is the same problem we took a look at, and we calculated the slope and the y-intercept by hand, which is what you'll have to be doing on your regression project. So your regression project is twofold. You're going to, number 1, make a scatter plot on graphing paper, draw the line that best fits through your data, and then go through doing this by hand, choosing 2 points that are actually physically on your regression line, and then finding the slope-intercept equation of that line that best fits the data. So, in other words, you're going to collect some data, and I'll give you some ideas, and you can search for some ideas for data collection. But if this were my scatter plot after I collected my data, I would then want to draw the line that best fits through my data. So after you, and of course you're going to label your axes. Remember, x is always the independent variable, the y is the dependent variable. So if you're doing something like stacking Oreo cookies, well, the height of the stack would depend on how many cookies there are. And so the number of cookies is your independent variable. And you're going to label your axes, number of cookies. And then the y-axis, you're going to label height of the cookies. Okay, so just make sure on your graph that you do by hand that you are labeling your axes. All right, and so here's a scatter plot. And I want to draw the line that best fits through the data. So you'll have to take a straight edge. This one I can see through it. And you're going to angle the line so that some of the points are above the line, some of the points are below the line. Okay, you could, if yours isn't see-through, you could hold it this way so that you can angle to try to get your line that best fits through the data. Don't try to force any points to be on the line. I'm thinking that maybe somewhere in here. I'm going to turn it a little bit more. But that would be the line. See, I've got these. This one's a little bit far away. So maybe I'll slide it this way a little bit. And I'm going to draw a line that goes through my data. So for me, that's what I'm estimating the line of best fit for this scatter plot to be. Now, when you do this by hand, you need to choose 2 points that are on the line. It just so happens that this point does appear to be on my line, so I'm going to circle it. And you want to pick another point that goes through the crosshairs of the grid. So let's see. This one looks pretty good right here. Okay, and so whatever those values are, I'm going to identify the ordered pairs. I'm going to use those 2 points to calculate the slope of my by hand line. All right, now this was just a generic example. I don't have my axes labeled. This was just a scatter plot that I made up. So, you want to make sure when you're doing it by hand, you get your data, you plot your points on the graphing paper, you label your axes. You definitely want to give a scale, whether you're going by 1s, 10s, 20s, 50s, whatever the case may be. Draw your line of best fit and identify 2 points on the line. I just so happen to have this data point on my line, so I'm going to use that point. And then I need to choose another point, preferably one that goes through the crosshairs of the grid, so I can easily identify its coordinates. All right, then we're going to use point slope. Well, you're going to use those 2 points, find the slope. Then you use point slope and convert it to slope intercept. All right, that takes care of that part. So I'm going to use this data table, which is on the bottom of our page, to go through how we put this information into the TI-84. So I'm going to move this paper over so I can put my calculator up here on the screen for you. All right, I already cleared the memory, so now I'm going to just hit clear. And to get data into the calculator, I'm going to push the button that says Stat, that's right here, underneath Delete, Stat, and I want to choose Edit, because I want to edit the information in the calculator. So I choose Edit, and these lists pop up. So I'm going to put my X values in list 1, and from the table, the X values are 0, so all you have to do is start typing. Type in a 0, hit Enter. The next value is 10. Hit Enter, 20, Enter, 30, Enter, 38, Enter, and 40, Enter. It's not a lot of points. It's not going to be a great scatter plot, but it is what it is. To get list 2 in your Y values, you're just going to hit this arrow over to the right, and it pops over in list 2. Then we're going to type in our values, 179.3, Enter. 203.3, Enter. 226.5, Enter. 250.0, Enter. 268.9, Enter. 281.4, Enter. Now I've got my list, my data set in the calculator. So I'm just going to hit second quit. It's in there, it's stored. Now I want to be able to actually see my scatter plot, so I have to turn the stat plot on. Now remember, when you clear the memory on the calculator, the window, aka the items that you're going to be able to see, is only going from -10 to 10. We're going to want to change our window. All right, the X-min and the Y-min doesn't really matter because we don't have any negative values. So I want to change my X max to, I don't know, I'm going to go up to 100. The highest X value is 40, but I'm going to go up to 100. And then my Y max looks like the highest value is 281.4, so maybe I'll go to 350. All right, so I changed the window, second quit, and I want to turn the stat plot on. So we're going to hit the blue button, second, and we're going to choose this Y equals. Above it, it says stat plot. Now notice the plots are off. We're going to hit enter, not just once, but twice to turn it on. And then hit graph, and you should see your scatter plot. Okay, if you want this to look a little bit better, I don't know, we could go into the window and change the scale to go by tens instead. Let's see if that makes a difference. Not really. It is what it is. All right, so here it says you may need to resize the window. You need to take into consideration your data. Also, when you're answering your question, it's customary to give the answer in terms of how the data was given to you. In other words, if you are rounded to the nearest whole number, then you round to the nearest whole number. If you are given a data set in terms of tenths, like this data set, then you're going to round to the nearest tenth. All right, get the regression slope and the y-intercept. You're going to hit the stat button, which is right here. I'm just going to hit that one time. Stat. And we want the calculator to calculate it. So I'm going to arrow over here to calc. We want linear regression right here, number 4. So you're going to choose number 4. And you're going to hit enter. That's going to give you the slope and the y-intercept of this line of best fit. Now I could take that information, don't clear the screen or anything. I want to transfer it right into the y equals editor because I don't want to have to remember what these decimal places were. So I'm going to have the calculator swoop that right in for me. So I hit y equals, and then I'm going to hit the vars button, right here, this one, vars. And we're working with statistics, so we're going to choose number 5, stats. Equation, arrow over to EQ. We want the regression equation, so hit enter. It dumps it right into the y equals editor for you, and now your calculator is going to draw the line of best fit once you hit graph. There it goes. Okay, so pretty close to what we saw on the scatter plot in the notes, if you take a look back here at it. Okay, so we're going to say that according to the graphing calculator, the equation calculated by the TI-84, we'll go, I don't know, to 3 decimal places. 2.457 times x plus, remember we're rounding to tenths, 178.4. All right, so at the bottom of our page, right here, the equation calculated by the TI-84 is y equals 2.457 x plus 178.4. 0.4. And now we're going to answer the same question. Use the equation to predict the population in the year 2010. Remember, this had an x value of 50. Now, I don't want to have to type this in. So what I'm going to do is move the paper up for that bottom part of the notes that I told you about. And say that we can actually trace on this graph. Right? The up-down arrow switches curves. And left-right moves along the curve. Alright, so maybe pause the video if you need to and get that copied down. We're going to go into trace mode so that we can actually get the y value that goes with that x value. So I'm going to put the graphing calculator back up here. I'm just going to hit trace. That's this button here. Trace. Now notice at the top of the calculator, it says P1, L1, L2. This means that your calculator is tracing on the scatter plot. So when you move your left and right arrows, it's going to move to each data point because it's going to the ordered pairs that are in your list, okay? Plot 1, list 1, and list 2. I'm going to choose the up arrow and push it one time, and when I do that, it's switching the curve or switching where it's tracing on. Now I'm tracing on the scatter, the line of best fit, all right? I'm tracing on the y equals the line. So if I'm in trace mode, I could just type in an x value of 50 and hit enter. And when I do that, it's going to give me the y value. So the y value looks like it's 301.3 if I'm rounding to the nearest 10th. 301.3. So TI-84 predicted population. The population will be about 301.3 million people. According to the TI-84 and the line of best fit. Okay, so if you forget to resize the window and you type in an x value of 50 and your x is only showing it, you're going to get an error. So just know if you get an error, that's an indication that you have to resize the window. I usually like to do that first so that I don't have to worry about it later. Run into a problem and try to think, why isn't this working? Okay. So you'll have a couple of worksheets to do using the TI-84. Hopefully you have a TI-84. I don't think Desmos does this. So you will need some sort of graphing calculator. If you have a TI-89, that's a different way of putting information into the list. I'm not real familiar with the TI-89, so you might have to Google something. You shouldn't be using a TI-89 for this class anyway. All right, this little note here. To obtain a y value for a certain x value, you're going to type in the x value, press enter. This only works in trace mode, and you must be on the regression line, okay? So again, that's what I showed you here. You know, if I go second quit, and I go graph, I'm in trace mode. Notice I'm tracing on the plot. You have to switch it to the line, and you can type in any x value as long as the x value is within that window that you chose. I did my x max to 100. So I can go back to the graph, go back to trace mode, make sure I'm on the line, and I could type an x value of 90 in there. So when x is 90, my y value is 399.6 right here at the bottom of the calculator. So I don't actually have to take an x value of 50 and substitute it into this model and calculate it by hand. I can have the calculator do it for me. All right. Two more things I want to talk about, and that is your ideas for your regression project and the rubric for the regression project. All right, this is the rubric for the linear regression project. It's okay to work with a partner. I don't mind that you do that to collect data. Of course, now with everything that's going on with social distancing, you may not be able to work with a partner. But here is how the project will be graded. Again, if you choose to work with a partner, you can't just hand in one project. You must hand in your own individual project. Your line of best fit, the equation, and everything else that you do by hand should not be the same exact as your partner's. Okay, because the chances of you drawing the same exact line through the scatter plot as your partner is slim to none. So keep that in mind. If you do choose to work with a partner, I need to know who your partner is. And I also am going to request that everyone send me a message to let me know what you plan on doing your project on. All right. So you're going to collect data and put it into a table. Okay, so if you were doing the Oreo cookies, investigating the height of a stack of cookies, I'm going to want to see a table of values. Okay, so you're going to collect data and put it into a table. 5 points. You will then plot the data points on a coordinate plane using graphing paper, just like I did here in this example. You're going to be sure to label your axes and use a proper scale. This has to be done by hand. That's 5 points. Number 3, draw the line that best fits the data, called the regression line. That's 5 points. Okay, if your scatter plot has a pretty positive slope and you draw a line with a negative slope, well, there would be something wrong there. So make sure that you're drawing your regression line properly. This part here, you have to give 2 equations. You're going to calculate and give the equation for the regression line. You're going to do one by hand, just like we did in the video before this one, and the one from the TI-84, just like we did in this video. That's 10 points. You're going to find the slope using 2 points on your regression line. See your notes. Here's a hint. Use the point-slope equation to get your slope-intercept equation. You're going to label the 2 points that you're using on your graph. I want you to circle them like I did and identify the ordered pairs. Remember, you cannot use data points for this unless your line goes through a data point. And don't try to force your line to go through data points. You must show your work for the by-hand equation. The next part of this is you're going to formulate a question that would predict future information about your data. Okay, so you want to give the equation, like in terms of x. In other words, my x value is, if I do the cookie data collection, my x values are the number of cookies. So my question I would ask is, what would the height of a stack of 40 cookies be if I follow this model? Okay, because notice I'm only stacking 10 cookies. So I could estimate what the predicted value of the height of a stack of 40 cookies would be without me having to actually stack up 40 cookies. All right, so I'm asking my question in terms of x so that I can calculate the y value. You're going to answer the question twice. Once with your by hand equation and once with your calculator, putting it in trace mode. This assignment is worth 40 points. You must have 10 to 20 data points on your graph. Okay, so the more points you have, the better regression analysis you are going to have. And you must include the rubric with your final project. All right, so your name has to go on it, and your partner's name if you did, in fact, use a partner. And there's something else I added on. I updated the rubric. I believe it said something in there about if you work with a partner, you each have to have your own project. I believe that's what it says. The rubric will be available for you to look at. I will make sure that it's in one of the folders after break. So over the break, I would like you to start thinking about what you're going to do your project on. Now remember, this has to be linear data, and it has to be something that you can collect the data. So here in investigating the height of a stack of cookies, here it says, using sandwich cookies and a centimeter ruler, measure to the nearest 0.1 centimeter the height of a variety of stacks. So, of course, if you have no cookies, the height of the stack is going to be 0. Then measure 2 cookies and 3 cookies and 5 and 7 and 10 and so on, and record your data in a table. So that's one example you could use. I've had students shoot hoops in their driveway. One student would do the timing, the other student would be shooting the hoops. So they did time trials of, 15 seconds, 30 seconds, 45 seconds, 1 minute, 1 minute and 15 seconds, and so on. And the person shooting the hoops would count how many they would make into the basket in those time trials. You can search data gathering activities, but please, please, please make sure that it is linear data. Sorry. All right, here. Students measure the height and foot length, no shoes, of at least 10 sets of data. So measure the height of a person and the length of their foot. Folks, you don't want to get everyone who's around the same height. You want to get taller people and shorter people, maybe even some kids. Students drop a ball from various heights and measure the height of the first bounce. Okay, you can, pause this video and read these to yourself if you want to. These are just some ideas. Students measure the diameter and their circumference of empty cans or jar lids. Okay, that will give you linear data. Well, you don't have an overhead projector, nor will you probably have access to one at your house, so forget that. Students will count the number of dry beans that will fill a jar lid without any overlapping. So you're going to need different size jar lids. Students will vary the length of a string and measure how the period of a pendulum, meaning the time to complete one swing across and back, changes. I did have a student that did this one year. Turned out pretty good for him. Number 7, if you have some dice, roll all the dice. After each roll, remove every die that is showing a 6. So you're going to need a bunch of dice for this. You can get them at the Dollar Tree, unless you have a whole bunch of dice in your house. This one here, draw different sizes of equilateral triangles with bases along lines of grid paper. Students should measure the size of the base and using the grid lengths, count the squares to estimate the area of each triangle. A little bit more time consuming. You can measure the height of a car and the height of its tires, okay, to get linear data. So if you have any questions, post it on the homework discussion. Talk about it in a Google Meet. It will be forthcoming when this project will be due. If you have any questions about how to use the TI-84 calculator, post a comment. Remember, I can't help you unless I know you need help. All right, well, you have a nice break and start thinking about your data gathering activity and maybe even gather the data so that you're that little bit more ahead of the game. You'll have some worksheets to do using your TI-84 and possibly even doing some stuff by hand. Again, reach out to me if you have any questions. Have a great day.